When someone gets a package delivered to their house, they usually see or hear the delivery driver pulling up before they get out and ring the doorbell. Now, there are two types of people. Those that wait for the driver to get the package, go up to the door, ring the doorbell, and then they'll go and answer it. And then there's the types of people who go up to the door and open it as the driver is walking up to the house. Now, in both cases, the person has sensed that the driver has arrived. But in the second situation, a faster, predictive and proactive interaction takes place compared to the first reactive one. Predictive interaction design is all about applying this idea to products, systems, services, and experience, hardware and software, and designing them to predict when an interaction will be made for faster, more efficient, or more secure user experiences. And this achieves that magical user experience that makes the user go, whoa, that was cool. My name is Nick Geary. I'm the founder of Predictive Interaction Design, and I'll be your presenter for this course. I'm an electronics engineer by qualification, and I've had a number of years of experience in innovation and UI and UX design. This course is aimed at people in engineering, UI and UX design, systems design, product design, and, well, anyone who's interested in further enhancing their experience and knowledge in the user experience and interaction design world. If you're a student, this should also be really useful for you to inspire your projects. This design thinking course is a combination of my knowledge and experience and is aimed to inspire new features and innovation into your products, systems, experiences, services, and projects. This course will be wholly example-led, so you'll be more easily able to follow along and see how predictive interaction design is implemented in real-world examples. I really hope you enjoy the course and find it useful. So, let's get started. Hey everyone, welcome to the Fundamentals chapter of the Predictive Interaction Design course. So let's get straight into it. What is predictive interaction design? Predictive interaction design is a design approach whereby a system state is preloaded, or certain components of the state are executed when there's a high probability that this state will be requested. This then decreases the delay or lag between the state being requested and the desired outcome being delivered. But this fundamental idea can also be reworked to increase efficiency and security. Now, the goal of predictive interaction design is to increase the responsiveness, efficiency, or security of products, systems, and experiences by thinking smarter instead of making them technically faster, more powerful, or increasing effort. So, let's approach this by asking ourselves a question. When the next state is requested, does the system have to load, initialize, or perform any certain actions that could be done before the state is requested if there was a high degree of certainty that this would happen? So if we're confident that a user is going to make an interaction, could we actually run some components or processes of the result of this interaction before the user actually makes that interaction? Then we need to ask, well, before a state is formally requested in the current system or experience, does an event occur that coincides with a high chance of this state being requested? So is there something that the user does, or is there a parameter that we can measure in the system that coincides with a high chance of them requesting that next state or interacting with the system, so that we can then run those components of the system beforehand as a form of essentially preloading the state that the user wants to request? Then we ask, can this event easily be measured, predicted, or recorded by the system? So is the system able to actually capture this event that coincides with a high chance of the user interacting with the system or requesting that next state? Now we can see how this is kind of coming together. Predictive interaction design has two fundamental core concepts. The first is intermediary states. So this is a system state where processes or components run after a prediction of an interaction is made, but before the interaction itself. Now this can take the form of three things: something called intermediary next state, silent next state, or light sleep. And I'll explain all of these to you as we go into the course. The second main core principle of predictive interaction design is prediction events. So this is a measurable activity, process, or parameter that can act as a trigger for the system to change to that intermediary state, or a lesser resource usage state, or this prediction event can act as a security condition depending on the implementation goal of predictive interaction design. And we'll be looking at lots of examples of all three of these goals: speed, efficiency, and security. Now, we can wrap all of that up into this graphic here. So we can see on the top row there, a traditional system where a system is in a specific state, it's perceptible in that specific state, and nothing is preloaded. And in a normal interaction, the user will then go and interact with that system. They will request state 2, and then after some time, state 2 will then be delivered to the user. Now we can see on the bottom, though, a system designed with the predictive interaction design approach. Again, state 1's perceptible, nothing's preloaded, but when an event occurs that indicates a high chance that state 2 will be requested, the system can preload state 2 so it can run certain components or processes without indication to the user, and then that means that by the time the user actually goes to request state 2 and make that interaction, state 2 then becomes perceptible with a faster response. Now in this graphic here, we say that state 2 is preloaded silently. This is the system entering an intermediary state, but it does it without any indication to the user, so that when the user actually goes to interact with it, it's pretty much got most of the components or processes already executed or loaded up, and thus state 2 is much faster. Now, we call this silent next state. However, as mentioned before, there are intermediary next states as well, which might not be silent, and then also next state suggestions, and we'll be breaking all of these down. So hopefully that gives you a little bit of an idea now of what predictive interaction design is. It's all about predicting when a user is going to do something, and it's all about running certain components or processes of the system when we make that prediction, or running less components for efficiency, or treating that prediction as a security condition to achieve their interaction or state request. In the next chapter, we're going to be talking more about silent next state, which I've just mentioned, and we're going to be looking at some examples of that. So I'll see you in chapter 3. Hey everyone, welcome to chapter 3 of section 1 of the Predictive Interaction Design course. Today we're going to be talking more about silent next state. So, in the previous chapter, we said that when a next state is requested, does the system have to load, initialize, or perform certain actions that could be done before the state was requested if there was a high degree of certainty that this would happen? And then we went over intermediary states. So these are system states where processes or components run after a prediction of an interaction is made, but before the interaction itself. This can take the form of an intermediary next state, silent next state, or light sleep. Now in this chapter, we're going to be talking more about silent next state, but we will talk about the other two further through this course. So what is silent next state? Well, silent next state is when a prediction event triggers certain parts of a system to prepare for a potential request or interaction. Now, all of these processes are quietly carried out without the user's awareness, and the term silent is used because the user isn't notified about any of these preparatory changes. Now, this is really good because if we predict that a user is going to interact with the system, and then we enter silent next state, but then the user actually doesn't interact with the system, well, the user has no idea that any changes in the system happened at all, so they won't have any form of unease with the system doing something without their direct request. Now, I've got some examples of some intermediary states here. Now, what we'll do is we'll go through these examples together and we'll go through which ones are silent next state and which ones are intermediary next states, because there are some nuanced differences. But in all of these examples, the system does preload certain components and processes in anticipation of a user interaction. So let's go from left to right. So in the first example, we've got the TV. So the intermediary state on the TV would be that the internal components turn on and initialize, but the screen and speakers remain off. So the user will have had absolutely no indication that any change to the system here has happened. Thus, this would be a silent next state. In the next example, we've got a website. So within the website itself, links that we predict that the user is about to click on are loaded in the background, but the next page doesn't appear yet. So the user, if they don't click the link, has no idea that any change has happened in the system, and they would be none the wiser. Now this, again, is a silent next state. The user has absolutely no indication that anything in the system has changed. In the third example, we've got a coffee machine. So the beans are ground and the water is heated, thus meaning that when the user requests coffee in their mug, the process will be much quicker, but the coffee's not brewed yet. Now, the user might actually hear that something's happening in the coffee machine. They would hear the grinder whirring away and the hissing sound of the water being heated. But again, remember, we're not giving them the result of their command, but they might perceive that some changes have been made. Now, this is an intermediary next state, where we prepare for the user command, but we can't actually do that in a manner that won't be sensed by the user. In the fourth example, we've got an automatic vehicle. So the transmission downshifts one gear in preparation for acceleration, but very importantly, the vehicle does not accelerate yet. Now, again, this is an intermediary next state. The user would sense, they would be aware that the system has downshifted a gear, but they still aren't given the result of their command. In the final example here, we have a smart speaker. So this is a ALEXA, I won't say the names to trigger anyone's speakers, or a Google Nest, or a Apple HomePod, for example. So in this situation, if the speaker predicts that a user is going to ask it something, it can establish a connection with the server and prepare for audio upload and run all of the processes in preparation for an interaction. But most importantly, the speaker does not respond or ask for a command or have any indication to the user that system changes have been made. This, again, is silent next state. Now here we've got something called the state change breakdown map. Now this is a tool that you can use to actually break down the low-level components or processes that run after an interaction in your system and define silent next state for your system. So what we'll do is we can fill this out given that first TV example. And the way we use this is we look at the very left and we have the state change component column. And what we do is we write down all of the individual components or processes that run when an interaction is made. And then after we do that, we tick which ones are perceptible and which ones are non-perceptible. Then we transpose that over to the right side of the state change breakdown map. And then we list all of the components in which we tick non-perceptible on the left column of that, and all of the perceptible components on the right column of that. And then effectively, we just have to look at the left column, and that is your silent next state. So if we have a look at the TV example, what we've done here is we have written down all of our state change components. So we've said internal hardware systems load and initialize, Wi-Fi connection is established, the display turns on and the speakers turn on. You can go as low level or as high level as you want in these maps, as long as it's appropriate for your system design. And all we've done is we've ticked which ones then are non-perceptible and which ones are perceptible. So internal hardware systems loading and initializing is not perceptible. The system establishing a Wi-Fi connection is not perceptible, but the display and the speakers turning on are both perceptible. And then all we do is we just look at what we ticked with non-perceptible and we transpose that over to the right section on that left column under non-perceptible, and we do the same with the perceptible. And then what we have under that silent next state column there, under non-perceptible, is the processes of our system that can run when a prediction's made that the user is going to interact with the system. So it's a super handy tool, very simple to use, and you can get as low level as you'd like, depending on the appropriate nature of your system design here. And what we've done there is we have decided that when a TV predicts when a user is going to interact with it, the internal hardware systems can load and initialize, and the Wi-Fi connection can be established, but we will only wait for the actual interaction itself for the display or the speakers to turn on. Otherwise, if the TV just turned on when it thought that the user was going to interact with it and the user had no intention to interact with it, well, they would be quite annoyed and also maybe a little bit creeped out as well. We kind of enter that uncanny valley territory there, and that is one of the golden rules of predictive interaction design, but we will talk a little bit more about those later on in the course. So that is intermediary states and silent next states. In the next chapter, we're going to be looking at mapping out the user journey before they make an interaction with the system, and how to measure and choose when to make the prediction to enter our intermediary state. I'll see you there. Welcome to the continuation of Chapter 3 of the first section of the Predictive Interaction Design course. Today we're going to be looking at mapping out the user journey before they make an interaction with the system. So previously, we've asked the question, before a state is formally requested in the current system or experience, does an event occur that coincides with a high chance of this state being requested? Now, the way to identify this event is to analyze the user journey leading up to the interaction and seeing if there's any certain action that they take that we can measure. But let's have a look at actually looking at that user journey. So here I've got something called the interaction map. And this is a blank canvas where we can write down all of the steps that the user takes before they make the interaction with the system. And we can have a look at all of the touch points and we can see what they do and then what the system also does. Now, as a continuation of the previous part of this chapter, we're going to be looking further at that TV example. Now, let's break down this map a little bit first for you. So at the bottom of the map, we've got time. So we go chronologically from left to right. And then we've got a row for the user on the upper section. So that's where we write down everything that the user does. And on the bottom row, we've got everything that the system does. And as we look through all of the interaction maps through this course, you'll get a better idea of how we can achieve those faster, more efficient or secure user experiences. So this is a blank interaction map, and this will be available in your course materials. And what you can do is you can print this out and you can write down from left to right on here. I personally use a tablet to do this, so I just write on the screen. But for the purposes of this course, we'll have a look at some filled in examples that I have actually written down beforehand. Now, if we look at the top, we've got a few other points. First, we've got the start of the user journey, and we call this the point of first environmental interaction. Now, this is the start of the user journey and is the earliest point at which we can practically measure that the user is going to have any indication of interacting with the system. Using any events or occurrences before this would probably not be practically possible to measure leading up to the interaction. Then we've got in purple a couple of prediction events. So these are the things that we measure to then enter intermediary state for our system. Then in red, we've got the point at which the user actually makes the interaction. And then at the end in blue, we've got the completion of the requested state. So this is the point at which the system has delivered the outcome of what the user has requested. And then in that kind of red box there, we've got the time taken between that interaction and the end of the requested state. Now, this is not to scale in terms of actual time, but this is to better help you visualize the process. This will be part of your course materials, and this is a blank interaction map. So best practice is to print this out and annotate, or if you've got a tablet handy, you can get an image of this up on your tablet and you can annotate over the top of it, which is what I'm going to do for this example. But for examples after this, I will save you from my terrible handwriting and we will look at pre-filled examples. Okay, so what I'm going to do here is I'm going to fill this in with the same example that we were using in the previous part of this chapter, which is the example of the user turning on the TV. So the challenge here is that the user goes and presses the power button on that TV. And with these modern television systems, it just takes forever to load up and for it to fire up. And then they just want to watch TV, right? And this thing's taking forever. So we want to make that experience faster for them. So let's look at all of these steps that the user takes leading up to the point at which they push the power button on that TV remote so that we can then deliver that faster interaction. So let's go with the start, which is the point of first environmental interaction. So this is the first point, again, at which it's practically possible to measure that the user wants to make an interaction. So, well, what we can do is we can write here that maybe the user enters the room that the TV resides in. So I'll just write here, user enters room TV resides in. So that's in the user section of the map. Now, if we look down at the system section of the map, well, the TV isn't doing anything. The TV is in standby. Now, what is the next thing that the user does that we could measure as a prediction for them wanting to interact with the TV? Well, they then go ahead and pick up the TV remote, right? So they then pick up TV remote. Then, after doing that, the user then usually points it at the TV. So user points remote at TV. Now, again, through all of this, the system is still in standby. And then the interaction itself, or the state request, is the user actually pressing the power button. So I'll write down here, user presses power button. And then it's only after this interaction is made that the TV then fires up all of its components. So I'll write this in the system section of the interaction map here, but after the user has interacted. So all components initialize and load, and then display and speakers turn on. Again, I will save you from my handwriting immediately after this slide. And then the end or the completion of the requested state in the blue there is that desired picture plus sound output is playing. Okay, that's much better. So what we've done is we've filled in the interaction map here. So we've got our challenge at the top. The TV is slow to turn on, and we want to make this user experience faster. Then if we have a look, we've got the point of first environmental interaction. This is the earliest point at which it's practically possible to measure that the user wants to interact with the system. And that's when they enter the room the TV resides in. Again, at the bottom, the system is in standby. Then the user picks up the TV remote. Then they point it at the TV. Again, while this is happening, the system is still in standby. And then at the point the user presses the power button, so that's their interaction or state request, the user then has made this state request, and then all components must now initialize and load, including the perceptible and non-perceptible components. And then the user eventually gets picture and sound playing after some time. Now, let's look at this interaction map with predictive interaction design implemented. So now what you can see here is that, again, when the user enters the room the TV resides in, nothing happens. The system is still in standby. Then after event 2 here, where the user picks up the TV remote, a motion sensor has been integrated into the TV remote that detects activity and signals to the system that it should enter silent next state. So then while the user is picking up this TV remote and then pointing it at the TV, all of the non-perceptible components are initializing and activating in the TV without the user's knowledge. And because this is a power state, we call this light sleep, which is a form of silent next state. We'll be talking more about light sleep a little bit later in this section. Then, by the time the user has pushed the power button, the system has had some time to preload the state request that the user wants, which is to be watching, TV with picture and sound. Then at the point at which the user has pressed the power button, just the perceptible components need to activate, which is the screen or speakers, and then the TV just instantly turns on, and that ensures that magical user experience. And even if there isn't enough time for the components to initialize fully, at least the interaction and user experience is much faster. And we can see that red zone there, that point in between the state request or interaction and the completion of the requested state, compared to the first one, is smaller. And that's the goal of predictive interaction design here. We're reducing the time it takes. We're reducing that delay, that lag between the user's interaction and the completion or delivery of the state that they're requesting. So this really helps us visualize all of the things that the user does before they make that interaction. Now we can see here that we've got 3 things that happen that we could measure, right, before the user interacts. We've got event 1, which is that point of first environmental interaction, and that's when the user enters the room the TV resides in. Then the user picks up the TV remote, and then they point it at the TV. But why have we chosen event 2 here? Why have we chosen the point at which the user picks up the TV remote to trigger the system to initialize silent next state? Well, we're going to be having a look at that in the next part of this chapter, where we look at a further tool we can use to break down the events that we've written down here and choosing which one to trigger the system to enter its silent next state. So I'll see you in the next part.